BC Calculus class. This is our digital learning day number 2 for Wednesday. We're going to be working on exponential growth. We had noted yesterday, and your homework from last night was that if the rate of change of some function was directly proportional to the original function, then y is going to be some exponential function where you have a times some base, and there's going to be some power of x. Okay? And that if given this fact and a couple of points, you can find both the a and the b, and you should be able to figure out the function. So a quick example, I tell you that dy dx is directly proportional to y. I tell you y of 1 is equal to 30, and y of 7 is equal to 10. And our task is to find the equation of y. We know that it's going to be exponential. In this case, it's going to be exponential decay. You'll note that 130 is here and 710 is here. So obviously we're talking a decay scenario here. Okay, so this is how we do it. And again, look at the previous video. You'll see this works reasonably well. We start with 30, the first point that's given, and then we take the ratio of the two y coordinates, so 10 over 30, and then we have to raise this to a power. X is our variable here, y is our variable here, so we're going to have x. Now this is going to be minus 1 divided by, let's see, 6, and let's see if that fits. Okay, so this is my equation, and you can sort of, as I go through this, you can figure out where the 1 and the 6 comes from. Okay, y of 1 would be 30 times 10 over 30, 1 minus 1 divided by 6, which is 30 times 10 over 30 to the 0. Anything to the 0 power is 1, so that's 30. Okay, so that checks. And my second point, y of 7 would be 30 times 10 over 30. And now we're going to put 7 in for x right here. Right, this is my x value, 7 minus 1 over 6, which is 30 times 10 over 30. And we have 6 over 6, which is 1. So 30 times 10 over 30, the 30's cancel, and we get 10, which matches our second point that was given. Okay? These are common problems. Here's a problem that was given on the multiple choice portion of the test. This is 1988. Bacteria in a certain culture increases at a rate proportional to the number present. So as soon as you see that, rate proportional to the number, so the rate of increase, I'll use n for number. We'll say t is time, is directly proportional to the number. And the number of bacteria doubles in 3 hours. How many hours will the bacteria triple? So let's go ahead and find the equation. First of all, we have one fact is that if time is 0, there's a certain number of bacteria. It could be 1,000, it could be 1. Let's just go ahead and put 100 in here. It doesn't matter because it's going to simplify anyway. And then it does say the number doubles in 3 hours. So now we have 200. So there's our 2 points. If you don't like those 2 points and you wanted to use 1 and 20, and 3 hours later 4 and 40, you get exactly the same equation. Or you get the same answer in the end. But let's just go ahead and keep it simple where the initial time is 0. Okay, so here's our equation. We have n is going to be the initial amount, 100. The ratio is going to be 200 over 100. And this is going to be t minus 3. And again, the more you do these, things will go reasonably well. You might want to double check the first couple of times. If you put, no, it's not t minus 3. Let's check this. It's t divided by 3. T divided by 3. That's a good reason to check. If you put t is equal to 0 in there, we get 200 over 100 to the 0 power, and that gives us 100. Okay, so I'm just doing a quick check here. N of 0 is 100. And if we put 3 in, we get N of 3 is exactly 200, sure, because the exponent would be 1, and so the 100s cancel and we're good to go. Okay, so that's the equation. Now let's answer the question, how many hours will the number of bacteria triple? So let's see. The number is going to triple. So we had 100, right? So we want the number to be 300. This is going to be 100. I'll go and simplify this to 2 right now, t over 3. And now we just have to solve this equation. We'll divide through by the 100. So 3 is equal to 2 to the t over 3 power. Okay, so I'll take the natural log of both sides. The natural log of 3 is the natural log of 2 to the t over 3. Or if you want, natural log of 3 is t over 3, bringing that out front, properties of logarithms, right? Remember, you can do that. So t over 3 is going to be the natural log of 3 divided by the natural log of 2. So lastly, t is equal to 3, natural log of 3 over natural log of 2. And that's the time we're looking for that as the answer, 3 natural log of 3 over natural log of 2. Okay. So there's an example. Here's another one. This was 1993. A puppy weighs 2 pounds at birth and 3.5 pounds 2 months later. The weight of the puppy during the first 6 months increases at a rate proportional to its weight. So there's the key again. The weight is increasing at a rate proportional to its weight. So let's say W is the weight. So the rate of change is proportional, directly proportional to its weight. So that's going to give us our exponential equation. The two data points we have are, let's see, we've got at 0 months, 2 pounds, and at 2 months, 3.5 pounds. That was given here. All right, 2 pounds at birth, and then 3.5 pounds 2 months later. Okay, so this is my time and my weight. Okay, so let's go and write down the equation. The weight is going to be the initial weight, which is 2. The ratio is going to be 3.5 over 2. And the exponent is going to be t over 2. And again, you might want to check to see that these two data points do, in fact, are satisfied by that equation. I'll let you do that. The task we had to do was how much will the puppy weigh when it's 3 months old. So W of 3 is going to be 2 times 3.5 over 2 to the 3/2 power. This was a calculator problem. So at that point, we just jump on our calculator and we say 2 times 3.5 divided by 2 raised to the 1.5 power. And we get 4.6. There's the answer. Okay, another example. Spread of disease. During a certain epidemic, the number of people infected increases at a rate proportional to the number of people that are infected. So once again, the number of people that is infected increases at a rate proportional to, so the rate of increase, let's do P for population. The rate of increase is proportional to the amount that's already infected. 1,000 people, so again, we're thinking T and P. So when first discovered, T is 0, and we have 1,000 people. And then 1,200 people 7 days later, so 1,200. And the task is how many are infected. Well, let's go and come up with the equation. Now that we have the shortcut here, it's real easy. P is going to be 1,000. And this is going to be 1,200 divided by 1,000. And that's going to be T over 7. You might want to double check that these two data points are satisfied by that equation. but the task was how many people are infected 12 days later. So we simply, P of 12 is going to be 1,000 times 1,200 over 1,000. And yes, you can simplify that, of course. I mean, obviously, divide by 100 and then divide by 2 if you want. So if you want to write 6/5, that's okay. Don't have to do that. No simplification required here. And then T is 12 sevenths. So that's our answer. Jump on the calculator, and we have 1,000 times 6/5. What's that, 1.2 in decimal world? 6/5, and that's raised to the 12 sevenths, and I don't know the decimal for 12 sevenths, so I'll just do it as 12 sevenths. And that's supposed to be raised to the 12 sevenths power. Okay, so I have 1,000, 1.2, and 12 sevenths power, and so we get 1366 is the answer. 1366.9, so 1367. Okay. Last example, this was in 1998. Number 84, population Y grows according to the equation. dy dt is ky. Somehow that got crumbled up there, but dy dt is equal to ky, so we have exponential growth. K is a constant, T is measured in years, population doubles every 10 years. What is K? Population doubles every 10 years. Okay, so our equation now is going to be, let's see if we have, it doesn't say anything about the initial population, but it does say it doubles. So let's suppose, again, we're just picking a number. Let's suppose there's 80 people in the town, and we have doubles every 10 years. So 10 years is 160, right? So our equation now is going to be the initial amount, 80. Here's the ratio, 160 over 80, which is just the number 2, and we have T over 10. So that's the equation. Let's go ahead and let's clean this up just a little bit. Y is 80 times 2 to the T over 10 power. And let's go ahead and get dy dt. dy dt is going to be 80 times 2 to the T over 10 power, and then times 1/10 from the chain rule, and then natural log of 2 because the exponential does not have a base of e. Okay? So what we were supposed to do, we were supposed to figure out what K was. So from here, K is going to be the derivative, right? dy dt divided by y. And we have the derivative right here. And we have y right there. So let's divide those out, put the derivative on top, and you'll get, let's see, the 80s cancel, the 2 to the T over 10s cancel, so we get K is 1/10 natural log of 2. And is that the choice? These are decimal problems, so let's see if we can clean this up. 0.1 natural log of 2. Okay, so 0.0693, 0.069. Okay, now, as those 4 as examples, your assignment will be to complete 10 similar problems. They will not be multiple choice. You'll have to type in the answer. Some will be calculator problems, so hopefully you have a calculator. If not, you can give me the exact answer. And that will be an editable Google Doc, right? And you'll submit that between 2:30 tomorrow afternoon or Wednesday afternoon to 5:30 Wednesday evening. Yeah, I'm recording this on Tuesday, so that's why I said tomorrow. But it will be done on Wednesday. Submit it. You get 10, all 10 right, A plus, 9 right, A minus, 8 right, B minus, 7 right, C minus, 6 right, D minus, 5 or less, F. And if you turn it to me before 2:30, please follow directions. If you turn it to me before 2:30, I'm going to go ahead and I'll ding you a letter grade for not following directions. Thank you. you very much. Hopefully I'll see you guys on Thursday.